Hello, welcome to another Data Classroom tutorial. We're going to take a look at a quick tidy data exercise, upload that data into a new data set, and then explore some of the ways we can practice the art of graphing using Data Classroom's easy tool for making professional looking graphs. So the data set we're looking at right here is from an elementary school classroom that wanted to test what types of paper treatments they could use to prevent water damage from hurting the legibility of their handwriting on that paper. We have here the rating scale that was used to judge the legibility of the paper, the different types of treatments that were applied to the paper, and then the different legibility scores assigned by the students in the class. This is a pretty cool experiment, especially for some elementary schoolers, but it is not currently in tidy format, not by a long shot. So in order to start, we need to create columns associated with each variable. The variables we've discussed and identified so far: the student who's making the observation, the legibility score, and the type of treatment it was given. So I'm going to go ahead and make those three columns to the right of our data here. We have the student, the treatment, and the legibility score. Now I've gone ahead and just come up with a random set of names, and we're assuming that they were made in the order that they were entered here. So for the first set of observations will be for coconut oil. So I'm taking the legibility score from coconut oil and copying it over here. Now for each one of these observations, the treatment in question is coconut oil. So I'm going to do that for each one of these observations. Now you can probably already tell by looking at this data set, we're going to have to deal with some vertical scroll here, which is a big reason why people have a tough time getting used to tidy data, because we tend not to like to have to do vertical scroll. It's a key user experience design on most websites to avoid vertical scroll, which explains, I think, why our normal aversion to it. But it's really important for computers when they're doing software analysis that each of the entries be a discrete entry and that each observation have its own row. So instead of having you watch me copy and paste all this information, I'll trust that you see the process. I'll do it one more time. So for our second round of observations, I'm going to copy and paste there. And now for Vaseline, I'm copying the legibility score for each observation. And I'm just going to input Vaseline as the treatment. So in order to format this data in tidy data format, we just repeat that process for palm oil, cocoa butter, canola oil, olive oil, and the control group. And then we would have data that checked all three boxes for tidy data. Each variable has its own column: student, treatment, and legibility score. One thing I didn't mention earlier was how it's important. The process of tidying data helps us identify our variables more explicitly, because right here, we don't even see the students represented. We kind of had to infer that from the fact that there was a consistent number of observations entered for each of the treatments. Again, each observation gets its own row, and then each value has its own cell. So I'm going to go ahead and take a selection of this data, copy it to my clipboard, and we're going to make a new data set here just by copying and pasting what we just tidied. I'm going to call this the art of graphing demo. All right, and we're well on our way to making a professional looking graph. First, we got to assign variable types for each of our variables. Now I'm now ready to graph. You could use the graph wizard if you'd like, but this is a simple enough experiment that we can just get right to the graph. So we're going to follow the rules of graphing. I won't belabor those here. If you'd like to see those, please check out our other YouTube video, the Teaching with Data cohort on graphing. And we're looking to see, is there a difference in legibility score across different treatments? So I'm going to show both these variables. select the scatter plot option, and now make sure that our treatment type, which is our independent variable, is on the x-axis, and our legibility score is on the y-axis. So we follow the rules of graphing. This is a graph. It is not a very artful graph. It does not answer our goal of communicating the data effectively. We can see that there's some story going on here, but it's not very clear what the distribution is or whether or not any of these are even advantageous treatments compared to just the control. So one of the first things I like to start with when I'm working on refining a graph using the art of graphing is to adjust the spacing. This overlap is not helpful, so I'm going to reduce the size of the dots to something that looks a little bit more manageable. You can see the graph auto-scaling to match it. Let's go right about there. I'm also going to play with the jitter. The jitter is the kind of arbitrary separation when you have categorical variables. I actually like the 2, so I'm going to keep that there. And now if we go back to our data real quick, we can see that the scale for legibility was actually 1 through 7. And I want to include that in my graph because it does tell a little bit part of the story, which is that none of the treatments received the highest legibility score that they set out at the start of the experiment. So to do that, going to the appearance, now my y-axis range, I call it a fixed range. And I'm going to leave 1 at the bottom, even though it's not very pleasing to have the points on the x-axis, but the 1 was the lowest part of that range. And so now we can kind of see that there is something happening here where none of them receive the highest rating. For the sake of spacing, I'm going to change my view as well to make our graph a little bit bigger. All right, one thing that's up next, color is an easy thing to help tell a story, and with categorical variables, assigning them each a different color makes it really easy to distinguish for them. I'm actually going to add that variable view back to assign different colors here. So we'll stick with gray for the control. Canola oil. These are all going to be arbitrary color selections. Sorry. If we had a live audience, I'd be asking for everybody's favorite color right now, but we don't. And another useful thing while we're in this view is you can also change the order of the different categorical variables as they're arranged on the x-axis. We're going to come back to that in a moment. Okay, so we're beginning to see a little bit more of a story. It's less harsh on the eyes to begin to sift through the data as it's presented, but we definitely should add some descriptive statistics here to get a better sense of the spread. All right, cool. So now we can see where the mean of the control group is. And that's a helpful waypoint for someone who's looking at this graph and trying to sift through the information quickly. I'm actually going to switch the location of the palm oil and the cocoa butter because we can see then that the palm oil will be grouped with the other variables that have a higher than average mean, or a mean higher than the control. I'm just going to fix the spelling of cocoa butter. And I'm going to move, like I said, palm oil up over cocoa butter. All right, I think we're almost there. This looks much better than it did before. I'm going to go ahead and switch my view as well. And now, just because I think students, especially when they're first beginning to work with data, strongly prefer bar graphs, I'm going to add a bar to represent where the mean is. And we can do that by going to the appearance, and scrolling down. How do we want to show the mean? We want to show it as a bar. And now I think we've much more effectively communicating the data that we got from our question. It looks like, I mean, we can't really tell if it's statistically significant or not, but canola oil and palm oil might be worth investigating further to see if they actually preserve the legibility of paper when exposed to water. Cocoa butter, Vaseline, coconut oil did not seem to help it compared to the control. Overall, I probably would just buy a protective folder, but in the event that you don't have that, looks like canola oil and palm oil might be helpful. And if we wanted to export this, the kind of the last steps of the art of graphing is to consider your audience. So this is going to go on a science fair poster. You want to be cognizant of how big the axis labels are. If it was going to be inlaid in a research paper, it would require different sizing as well. But I think that we've done a good job of keeping our audience in mind here, from things like including descriptive statistics that are reminiscent of a bar graph, to using colors and spacing to make this data much easier to interpret. Because the ultimate goal, right, is that we're telling a story with data in the same way that you want to write a really clear sentence to express what you're trying to say. You want to be able to create a really clear graph that expresses what you found as a result of your experiment. Thanks for joining us. Stay tuned for more tutorials like this from DataClassroom.